Hello there, welcome to this video. We are going to talk about simplifying trigonometric expressions, all right? And I'm going to go ahead and split this video into two. The first video is going to focus just on simplifying down trigonometric expressions with lots of substitution, and then the second video will focus on factoring trigonometric expressions. All right, so let's go ahead and introduce you to Pythagorean identities. Now, the Pythagorean identities are very important when working with trigonometric expressions and equations, and they're derived from the Pythagorean theorem. So we'll go ahead and look at this inscribed triangle in a circle, and I hope that you see it is a right triangle, right? So that means that if I let the two legs, okay, be x and y, and my radius be 1, I can get x squared plus y squared equals 1 squared. And substituting our knowledge of trigonometric expressions, right, your x value is cosine theta, and your y value is sine theta. So if I go ahead and I have x squared plus y squared, well, that's now cosine theta squared plus sine theta squared is equal to 1. And this gives us our first and major Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And just kind of a note about trigonometric expressions and kind of notation here. Cosine theta quantity squared, this is equal to cosine squared theta. So it's just a little notation thing that they do when you have cosine theta and you square it. They just move that square kind of between the trig function and theta. I don't know why. They just do. Okay, so from this, though, what I can do is if I start out with sine squared plus cosine squared equals 1, and I now go ahead and I divide by sine squared theta, I come up with another trigonometric or another Pythagorean identity, okay? And that is 1 plus cotan squared is equal to cosecant squared, right? And I get this because if I divide sine squared by sine squared, that's 1. If I divide cosine squared by sine squared, well, that's cotangent squared. Okay, and if I divide 1 by sine squared, well, that is cosecant squared. Okay, so that's how you get the next trigonometric identity. And then the third, Pythagorean identity is by doing the same kind of thing. Now I'm going to go ahead and I'm going to divide everything by cosine squared theta. So what is sine squared divided by cosine squared? Well, that's tan squared. Okay, and what's cosine squared divided by cosine squared? Well, that's 1. Okay, and then 1 divided by cosine squared, that is secant squared theta. So here's your third one, okay? And this brings us to our Pythagorean identities. Okay, and they're here in bold. These are the three that you should memorize, and if you can't memorize them, then I would just focus on number 1, because I showed you the process for obtaining 2 and 3. You just divide by sine squared and cosine squared to obtain the other ones. So I can also manipulate the first one, right? If I have sine squared plus cosine squared equals 1, I can move stuff left and right with subtraction. So I could, if I want just sine squared theta by itself, okay, I can move over the cosine squared theta. If I want cosine squared theta by itself, I can subtract over sine squared theta. So you have just kind of all these manipulations, and on the test, I recommend always just writing down at least your first one from memory and obtaining 2 and 3. Just so you have them there to kind of reference, okay? This is a great time to enable flashcards. I'm old school. I like using index cards and flipping through them and quizzing myself and friends like in the class, right? Like, what is sine squared plus cosine squared theta? Go. And they better say, 1. That's easy. And I'm like, yeah, it is. Okay, or if you like using digital flashcards like Quizlet, feel free. Okay, so those... excuse me. Okay, those are our identities. Now let's go ahead and see, okay, how can we apply them? Oh yeah, I forgot. We have these identities too, reciprocal identities and quotient identities. Again, with the main ones being here, generally we go from cosecant and secant back to sine and cosine. And then 2, we have our quotient identities, right? Tan theta is sine theta over cosine theta, and cotan is cosine theta over sine theta. So those are our identities. All right, let's go ahead and look at kind of the steps and strategies for simplifying a trig expression. Step 1, substitute using the identities. And it's very easy to substitute using these identities because you're going to see the squared, sine squared, cosine squared. Whenever you see a trig function squared, it's kind of like poking at you like, hey, you're going to use a Pythagorean identity. Step 2, factor. Okay, we're going to use basic factoring skills. 3, distribute. 4, get a common denominator. 5, multiply by a ratio of 1. And then 6, if all else fails, rewrite everything in terms of sine and cosine. We're going to be doing that a lot lately. Okay, and then the question becomes, how do I know if I have a fully simplified trig expression? Well, the expression will be written in terms of only one trig function. So just only in terms of sine or only in terms of cosine. Step 2, the expression does not involve any fractional forms. So we don't want fractions. And then step 3, no more identities can be used to further simplify the expression. Okay, so now that we've kind of oriented ourselves, let's go ahead and look at some examples. Here is our first one, and they want us to simplify the expression. Okay, so the first thing that I'm going to go ahead and do here is I am going to factor out the sine of x. I hope you see that we have a sine of x in both terms. So this gives us sine of x times 1 minus cosine squared x. Okay, and then here's where we're going to go ahead and we're going to jump over to our Pythagorean theorem identities. I see a cosine squared x there, so I'm going to go ahead and just write this. So sine squared x plus cosine squared x, this is equal to 1. So notice I kind of have something that looks similar, but if I subtract cosine squared x over, I get this. Sine squared x is equal to 1 minus cosine squared x. And hey, don't you see this right here? Okay, so I can go ahead and substitute. This is sine of x, okay, times sine squared of x, right? Which is the same thing as sine of x times sine of x squared. So this becomes sine of x cubed, okay, which is the same thing as sine cubed of x. And there is your answer, right? Very straightforward. You don't have to do these kind of intermediate steps if you understand like the notation and kind of like what's going on. All right, here is the next example. So same type of idea here, right? I hope you see that we have a cosecant of x in both terms. Okay, so I'm going to factor that out. So this is going to be equal to cosecant of x times 1 minus cosine squared of x. Okay, well, didn't we just say that 1 minus cosine squared of x is equal to sine squared of x? We did. So this is cosecant of x times sine squared of x. Okay, and I'm not going to go ahead and multiply these together. I want stuff to kind of simplify. So I hope you have your thinking cap on, and I hope when you see cosecant of x, I hope you think of your reciprocal identity. Isn't cosecant of x equal to 1 over sine of x? And it sure is. So I have 1 over sine of x times sine of x, right? And this is squared. So, and I'll put this over 1. So can't I go ahead and cancel? 1, 1, right? And our answer is sine of x. Look at that, right? Not too bad. That's pretty simple. Okay. All right, here, notice I don't have anything squared. Like there's nothing that's screaming, hey, substitute me. And I don't have anything that's similar, right, to factor out. So when we look at things like this, generally what we're going to do is we're going to kind of target like our reciprocal identities. So I hope you see that this is sine of x plus cotan, right? And cotan is cosine over sine. Okay, that's over 1. So those are similar. Again, all I did, right, was substitute out cotan of x. That's cosine over sine. So now I can go ahead and multiply my sines together. So I have sine of x plus cosine squared of x over sine of x. Okay? Well, I mean, that didn't really help much. I mean, well, actually it did. But what can I do now? How can I like add these together? Well, in order to add fractions, you have to have a common denominator. Okay, so I think what I'm going to do is I'm going to multiply sine of x by a ratio of 1. And I can do this, right? Because sine of x divided by sine of x is 1. So if I multiply something times 1, isn't it itself? So I'm not really changing it, right? This is what we call a multiplicative identity. It's the same thing. I'm not changing it at all. But watch what happens. When I change the structure by doing this, I get sine squared of x over sine of x plus cosine squared of x over sine of x. Okay, and now I have a common denominator. Now I can go ahead and add these. I get sine squared of x plus cosine squared x all over sine x. Okay, so, and I hope right away at the top, I hope you see this and you're like, hey, that's our Pythagorean identity, right? Sine squared plus cosine squared is equal to 1. So this is 1 over sine of x, which is cosecant x. Okay, boom. Simple, easy, lots of flashcards. If you're struggling like with this, you're like, whoa, my head is spinning. Flashcards, flashcards, flashcards. And some more flashcards, okay? Like, seriously, like 10 minutes every night before you go to bed. Like, maybe when you're in the bathtub playing with rubber duckies, okay? You just flashcards, right? Or you're in quarantine, right? And then Netflix is like, you know, there's nothing on it. There's nothing on it anyway. It's like, man, come on, put some new stuff on there. All right. Page 9, the next one. We want to go ahead and simplify this. And whoa. Okay, so this one's looking really, really weird. What we have going on is a whole bunch of co's. So again, like I said, there's nothing squared that I can substitute. I don't have anything I can factor. So let's go ahead and put everything in terms of sine and cosine, right? And I'll put this strategy down on your paper. Put in terms of sine and cosine. Because a lot of things will start to reveal themselves when you do this. So cosecant, that's 1 over sine of x minus, okay, cosine, that's fine, that stays. I'll put that over 1. And then cotangent. Well, I know that that's cosine of x over sine of x. Okay, well, I'll combine these two, right? So that gives me 1 over sine of x minus cosine squared of x over sine of x. Okay, and hey, common denominator, I can add these. This is 1 minus cosine squared of x all over sine of x. And didn't we say that sine squared of x is equal to 1 minus cosine squared of x, right? That should seem familiar. Okay, so I have sine squared of x over sine of x. Okay, and again, we have some cancellation, right? This cancels with this, and you get sine of x. There's your answer. All right. Okay. So that is going to do it for this video. The next video that I will show you will focus on factoring. We're going to factor some of these trigonometric expressions. All right, catch you next time.